So here we have the Mystic Circuits 0 HP VCA and gate. We have an input, an output, a CV input, and a trigger that this generates as well. 0 HP, dangles on your cables, lovely and free. I'm really bad at poetry. Let's check this thing out. So to start with, let's have a look at how this responds as a standard kind of VCA. Now most people are running audio to the input of a VCA and an envelope to the CV in. So this is my audio source, and I'm going to start off my envelope looping. Envelope is the blue source coming into the CV in. We can see that on the pink LED. That's the blue trace. Audio, and here's the out. Now we're not getting a nice smooth decay as we've got there. It actually cuts off a bit, and there's a little bit of drive and fuzz, which is quirky and nice and something different. If I mute its output and just let you listen to the oscillator droning, which is this green trace and the input to the device. It's free sine waves tuned to intervals for a little chord sound. Now listen to that kind of fuzz and hairy end where it cuts off at the end of these little phrases. Now if I change the shape of my envelope to be an exponential fall, cuts off even sooner. It will also generate a trigger for us. And this is as it opens up. So I've got the trigger out, opening up another envelope, setting off another two-stage function generator, and let's make that pitch up one of the oscillators in this chord tone. So here we're using the AND gate VCA to merge CV, much like using a VCA to affect the amplitude of another CV source. Now our CV input is this top trace, this green two-stage LFO, triangle-ish LFO. But what it actually does is, I guess this is part of it being a passive design, it doesn't cleanly follow this CV, and it is a unipolar CV going from 0 volts positive. It's not a bipolar LFO, but it kind of clips off the CV input a little bit, which in this case is then taking this blue trace as the input here, giving us a kind of stepped version of this wave. Now if I speed up the CV input, this green trace, and go even faster, it will work at audio rate. Now if I change the shape of this input LFO to be more exponential, we get thinner, little kind of rising triggers on the output. Now I'm going to speed up the input wave, which is this blue trace. And let's swap these around and see what we get. So this is then CVing this source, and that is the input. And with a faster now input and slower this blue trace CV, you can see the response of this. It doesn't quite smoothly fade in and out as that blue triangle would suggest. It's more of an on-off style response. It's great as a passive, quirky-ish VCA for CV. I've been having lots of fun merging LFO and envelope signals. We can also take this trigger out. So I'm now coming out of the trigger output. And this, we get these kind of blippy, trigger-ish versions. Again, it's all a bit ish and a bit approximated, and I guess this is because it's passive, but I like that. I like that it's not perfect, and it makes it fun working with two CV sources, or audio and CV, or just audio, like the other 0HP units. What a little gem. So let's look at how this AND gate / VCA responds to audio rate. I have a triangle LFO, and as we've seen before, putting envelopes into this thing like a VCA, it does square these off, so it's more like gate on an off style response as opposed to smooth CV. But it works great right up through audio rates. It's fantastic at adding overtones and creating FM and AM, more additive style tones that don't mess with the fundamental frequency like, say, analog FM. This blue trace is my input. It's kind of clipped-ish sine. And the yellow trace is the output of the device. Let's turn up my LFO that is modulating this on this yellow cable and check out the potential overtones. Nothing like a sine anymore, and in tune it works great as an almost PWM style overtone generator. Let's get a sequence into my sine wave oscillator and see how it responds. It's a little bit dissonant, so let's split that Volt-Proctive signal up into my LFO / audio rate modulator as well. Let's move the carrying sine wave tone down an octave. And up an octave. And again. And those beating unison style sounds work great. Let's go back to where we were and play with the octave of the modulating oscillator. My input waveform has an option to be wave folded. This is braids from Mutable Instruments. So let's fold that input wave, this blue trace, and see what response we get. Oh, it's nice. So let's get a higher modulation rate and then try the folding again. higher rate again. So for this final patch, we're going to look at this as a logic, Boolean logic and gate. Now, Boolean logic tends to have two inputs, an A and a B, and it just deals in high and low states. So this is binary, it's 1 or it's 0, it's on or it's off. And we can think of gate and trigger signals as binary, on-off, high and low signals. Now, if I mute this rhythm, you'll see a gate rhythm on the yellow trace. That's going into the CV input. We can see that light up this AND gate. Every time this lights up, it's going to let a signal through, because an AND gate needs a high signal at both of its inputs. If this was a traditional logic style module, we'd have an input A and an input B, and both A and B would have to have a high voltage for there to be an output. My input is this blue rhythm, which is currently triggering my hi-hats in the background. The yellow one is the kick. So what you can see on the green trace is the output, and when this gate is high and these fire, the rhythms come through on the green trace, and that's the output of this AND logic. So let's put my sound back in that's been triggered by the output of the device. So you can see and hear, as long as that yellow trace is open and there's blue signals, blue triggers for the hi-hats, we get a rhythm. I'm going to change the yellow trace, which is the CV on here and the kick drum sound. And that's the basics of it being a logic AND gate. Now I've got sequencing, modulation and some effects set up. Let's get some pitch sequencing going into the percussive sound that this output is triggering, the green trace. And some modulation. And some effects. And while this blue rhythm stays static, I'm going to play around with a kick drum rhythm, influencing the output to this percussive sound going into my effects. I'm going to lose the hi-hat. So that's the Mystic Circuits 0 HP VCA AND gate. Another wicked little 0 HP unit. Check out the videos that I've done on the other two modules so far for this in the description. Thanks for watching. Go support me on Patreon if you'd like some extra content. Cheers.